You said 55?
Yeah.
Okay, well, you said 55 on page 129?
Yeah.
So we have cosine x. It says equals x cubed. So we only want to show how to determine a solution with whatever number of decimals, right? Okay, so you can, in the graphing calculator, it doesn't matter what you do. So you can put it as two different functions. You can put it as one function. If you want to put it as two different functions, you will find the intercept. If you want to put it as one function, then you will find the zero. So which one would you like? Would you like to put it as one function, or would you like to put it as two functions, y1 and y2?
One function.
One function. So then I will have cosine x minus x cubed. Cosine x minus x cubed. Good. So then we go to second and calc. Since we put it in as a function, we are going to determine the zero of the function, or the x-intercept. So 0. Okay, so the calculator will ask me to determine a so-called left bound and right bound. Why is the calculator asking for that? It's because I may have 5 solutions, and the calculator doesn't know which one I want. Since in this case there is only one, I'm going to say between 0 and 2. So I can also change the viewing window, right? So if you want from -2 to 4, and with a scale of 1, and from -2 to 2 with a scale of 1. So I see clearly that the intercept is somewhere between 0 and 1. I don't have to go to 2. So, right?
Wait,
So,
I did it in the table.
no. So second and calc. So one more time, we're determining the 0. It's asking us now where is the left bound. So I want 0 as the left bound. I want 1 as the right bound. And I don't want to guess. Just give me the answer. And it gives us enough decimal digits. I hope you can all see. Point, if you can't, just make some arrangement, or I don't know what to do with this. We can, as I said, initially, we can move the tables further to the right a little bit. If you feel like it, push them to the right. So it's 0.865474. 0.865474. This is how we determine using the graphing calculator. So, Braden, I forgot. Ricky has a little bit of a problem with you there. So can we just move a little bit closer? Let's see. I forgot. Ricky, can you see now? Is this better?
Yeah.
Okay, so this is how we determine. Now, in chapter 4, when we talk about Newton's method, forgive me, I forgot. When we talk about Newton's method, we don't need to do this. We're going to be able to find solutions very easily. Very easy, not with,
And I'm trying to find letter B.
Yes, that's your B that you showed me, yes.
Letter A is just between 2 and 1.
So the letter B is using the IVT.
Okay.
That's a different story. You cannot find it. IVT does not help you to find it. It helps you show that there's a solution between this and this, but it does not help you find the actual solution. That's why part B was asking you to find the actual solution. IVT does not help with that. It only gives us an idea of where it is. Okay, very good. Next question, is there anything else?
Page 41.
Page
41.
41?
141.
141. Okay, number?
23.
141, number 23. Yes, what happened to that one?
We just don't know how to start it. That's really what the problem.
Okay, what if I do 24 and you do 23 for next time?
Okay.
Is that okay? Is this okay now?
Yeah.
Okay, so let's do 24. 141. And in 24, we have limit as x approaches negative infinity. This is very similar to the problem, the long problem we did, which was 26. Very similar. But let's see one like this. So the square root, 9x to the 6 minus x, and everything divided by x cubed plus 1. Okay, what is the first step?
Rationalize.
The first step is to check what it is. So, which of the two? Yes, please. Chris? Oh, very good. Do we all agree with infinity over infinity, even if it's positive or negative, we don't really care? Because between these two terms, which one is the most powerful? Right. And if I plug in negative infinity to the 6th power, what do I get? Where does this term go? To positive infinity. And the square root of positive infinity is infinity. What about here? Which of these two is more powerful? If I plug in negative infinity to the 3rd power, what do I get? Negative infinity, but the sign doesn't matter. Okay, ready? So what is the degree under the square root? The degree under the square root is? Very good. This is exactly what we need to factor. What is left in parentheses? How many terms? 2 terms. And what is left? Yes? Minus?
1 over x 5.
Very good. 1 over x to the 5th. Awesome. What is the degree in the denominator? Good, so let's factor it then. What is left? Very good. Yes.
1 over x 3.
Excellent. Perfect. You can't simplify or do anything just now. Now, this is a product, a square root of a product. We are allowed to write the square root of A times the square root of B. I caution you because I saw it in your work. The square root of A squared plus or minus B squared does not equal the square root of A squared plus the square root of B squared. Please do not make this mistake. With a product or a ratio, yes. With a sum or a difference, no. Good, so then from here, I continue here. What will you write? I have to apply this rule. So the limit, yes, very good. Limit as x approaches negative infinity from the square root of, very good, times the square root of, very good, awesome. And now the denominator stays as is. Here, thank you. Thank you very much. Good. You mean here?
Well, I mean, like, in the limit, I thought it was like infinity.
Oh, did I copy incorrectly?
No, 24 is negative. 23 is positive.
This number 2.
Yes. Very good. Always keep an eye on what I copy because sometimes I do copy something else. I say one thing and I copy something else, not by intention. Okay, so now, remember what happens with the square root of x to the 6th. The answer should be the absolute value of x to the 3rd. But since x approaches negative infinity, I can replace the, I'm going to write it anyway for you. So let me write it. So the square root of x to the 6th is the absolute value of x to the 3rd. But this can be replaced by what? Knowing that x approaches negative infinity. Negative x to the 3rd. What would you have replaced it by if x were to approach positive infinity? What would you have replaced the absolute value of x cubed by if x approached positive infinity? X to the 3rd. X to the 3rd. Why? Let me write another note for you as a refresher. The absolute value of x is x for positive and negative x for negative. Since this is x cubed, it's the same thing. X cubed and x cubed. So the absolute value of x to the 3rd will be replaced by negative x to the 3rd if x approaches negative infinity. So now coming back, only now I can remove this. Only after I analyze it what it equals to. I cannot just blindly say x to the third. That would be incorrect. So then we continue here with a square this time. So limit x approaches negative infinity, negative x to the third, 9 minus 1 over x to the fifth over x to the third, 1 plus x to the third. Okay, now what will I get rid of? Definitely and immediately. Exactly. And now I can say, at this point, I drop the limit operator because I'm applying the limit operator to this. It's gone. So where does this go when x approaches negative infinity? Awesome. Where does this go when x approaches positive or negative? It doesn't matter. 0. So then the final answer is exactly. But it has a negative in front, so it's negative 3. Yes, please.
In the beginning, when you
Yes.
pulled out the 9x plus 6, couldn't you multiply it by 1 over x cubed?
Inside square root, no. Unless you multiply, so you want to multiply the top by 1 over x to the third, and when you put it inside, it becomes 1 over x to the sixth. Be careful with that. I don't disagree with the method, but first of all, you have to say that you are multiplying this by 1 over x cubed, and you multiply this by 1 over x cubed. But when you plug it in, it has to be 1 over x to the sixth, and then you have to be very careful with the sign. So careful. I accept other methods, but just be careful. Okay, so the answer is negative 3. What do we conclude? Y equals horizontal asymptote for sure at negative infinity only. We only discussed what happens at negative infinity. We don't know what happens at positive infinity. I guarantee you that the asymptote will not be negative 3. Y equals negative 3. So please make sure that you write that down, that at negative infinity. Very good. Other questions for me? Anything else that you worked on? Anything else? Yes, please.
We did this last class.
Yes?
But number 21 on page 141.
Yes?
I just wanted to go over it.
Yes. Can we go back to the previous notes and you tell me what was not clear?
Yes.
Okay. Okay. So first of all, I see a binomial squared. Can anyone give us just the first term of this binomial? 4x to the fourth, correct? Plus 2 plus 4x squared plus 1, right? But that's it. Okay. What do I have here? When I square this, I would have an x squared. And when I square this, I would have, when I multiply an x squared by an x squared, x to the fourth. So the top is 4x to the fourth as the first term. The bottom is x to the fourth as the first term. Nothing else matters because they're all so much smaller. So it's 4 over 1. But let's see how we went through it. So we wrote the top as 4x to the fourth plus 4x squared plus 1. And we distributed the denominator, right? So we squared this as x squared minus 2x plus 1, and then we distributed x squared to all 3 terms and x to all 3 terms. And then we combined like terms and we simplified, and we got this. 4x to the fourth, 4x squared plus 1, and then we combine these like terms. But nothing really matters but the very first term, because all the other ones will be 1 over x or 1 over x squared or 1 over x cubed. Everything will go away. So we factor the degree, which was x to the fourth. We factor the degree, which was x to the fourth. The remaining term at the top was 4. The remaining term at the bottom was 1. Everything else cleared out. Because this approaches 0, this approaches 0, this approaches 0, and everything approaches 0 except 4 over 1. Does that make sense? Better? So then we conclude that since it's a rational function, this will be on both sides. But to be safe, we wrote positive. But it's rational, it will be on both sides. Good. Anything else? Yes, please. Ricky? Sorry.
X and B to
I'm answering what?
Or like do like weekdays?
Yes. So if you have any questions on that, we can. But not in class.
Oh, okay, so
R-
after class.
Yes, after class. Yes.
Oh, okay.
You're talking about the quiz or the? I have a quiz for you, but since I started,
I mean,
I'm.
like the homework,
Yes.
explanation.
You can turn it in next time. I already sent you the homework solutions.
Oh, okay.
Yes. Sorry. Good.
I was just gonna say, can you go back to 24 really quick?
Yes.
21?
The one that we just did?
Yeah.
Yes, of course. Oh. Last part, first part. Anyone else? Other questions for me? Yes?
When many people get to 29?
Yes, of course. What was the problem with the 29?
Well, I think about the answer, I just wasn't really clear on.
As long as you factor out the degree at the top and the degree at the bottom,
Okay.
you don't make conclusions about top and bottom based on the other one. You factor out the degree. So let's also look at that. Limit as x approaches infinity. The numerator, x to the fourth minus 3x squared and plus x, and everything over x cubed minus x plus 2. I don't care about the other one. The degree is x to the fourth. I don't care about the other one. The degree is x to the third. And you put in the whatever you have. You simplify. And you get the answer. Is that good enough?
Okay. Yeah,
Is that enough?
I think so, yeah.
Okay. That's all we need to do. And then we write the answer without the limit operator. Is that okay, everyone? Is that okay? Is that good enough? Yes, please. Dylan, go ahead.
What is the answer? Just X.
You have to put in the terms in parentheses first. That's what I'm asking. Is that good enough? Or should I? Yes, Brian? Yes. Yes, of course. So we have 1 minus 3 over x squared plus 1 over x to the third. And we have 1 minus 1 over x squared plus 2 over x to the third. All these are 0. 1 over 1 with x in front is infinity. Anything else? Anything else? So,
Wait,
yes?
should it be just 1 over 1, which is just 1?
X to the fourth over x to the third don't go away. There is an x left in there. This whole thing approaches 1, but you have an x. And 1 times infinity is infinity. But there is no horizontal asymptote here. Yes, Vanessa?
I'm confused to why you divided the terms by x.
This is what we did last time.
I don't understand that one though.
So this is what we did last
Also,
time.
I know how to factor it, but I don't know why you use like 2 and 3 for the x and for the.
I factor the degree. As I said, I don't look at the denominator to make the decision on what I factor out in the numerator. The numerator has degree 4. I factor out degree 4. The denominator here has degree 4. I factor out the degree 4. Here in the previous example that we just looked at, the numerator has degree 4. That's what I have to factor. The denominator has degree 3. That's what I have to factor. I can't make a decision based on the other.
So if it's here factored by the degree 4, then why is the last term on the numerator x cubed?
X to the fourth over x cubed is x. Right? There is an x in there.
Yeah.
But here I don't have an x. It's 2. So that's why I only have 2 over x to the third. But over there I have an x. So when I distribute this back, x to the fourth over x to the third, I have to get that. So I can factor out everything, anything I can think of, as long as these 3 terms, when I redistribute x to the fourth to them, I get the initial problem. I can factor out 1,000,000 from each term, as long as I have x to the fourth over 1,000,000 minus 3x squared over 1,000,000 plus x over 1,000,000. Does it make sense? I cannot factor out more than a degree in each polynomial. Good. Very good question, actually. Next question. Anything else? Anything else? Okay, so let's go back to, I didn't forget about the quiz. We're going to look at it. But let me, since I started my video, let me do an hour and then I'll give you the quiz so I don't stop it and have 10 minutes and then, okay. What I would like you to choose as the next problem is something like this. On page 140, from 5 to 10. We'll always look at examples like this in which we are trying to create a function given certain conditions. So I would like you to pick an even number problem so I can give you an odd number problem to work on, but it's up to you. And if you don't pick in 1, 2, 3 seconds, I will. Okay, thank you for the vote of confidence. I'm going to pick 6. I like it when my students allow me to pick a problem. That's good. So limit of f of x as x approaches 2 from either side. Watch what I copy. I have to give that task to someone who would like to make sure that I copy correctly. F of x equals infinity. Limit of f of x as x approaches negative 2 from the left. From the left, what is it? Negative infinity. And then limit of f of x is 0. As x approaches, I think, negative infinity, yes. Limit of f of x as x approaches infinity is also 0, and f of 0 is 0. Okay, I hope I copied everything correctly. Please let me know if I did, if I didn't. Ready? Yes, am I okay? Remember what we do with problems like these. What do we do with problems like these? Thank you very much. Please summarize all the information so you don't make a mistake and make sure that everything is in the table. So here's what I would like to start with. When x is 0, y is 0. Then I would like to continue with limit of f of x as x approaches negative infinity is 0. Done. And when x approaches infinity is also 0. Done. I will immediately write y equals 0 must be. Y equals 0 must be. Excellent. And now I see that something happens at 2, and something happens at negative 2. So, negative 2 and 2. And let's see what happens at those 2 points. Here it says limit of f of x as x approaches 2 from either side is infinity. 2 from either side is infinity. This clearly, so this is taken care of already. This clearly says that if the limits left and right are infinity, it is a possibility, not necessarily, this is my choice. The function may be defined based on piecewise, who knows? And my choice is to make this a vertical asymptote. That's my choice. So I will say x equals 2 is a VA. Although the function, if you would like to come up with a different example, you could. And say, oh, the function is defined somewhere. Fine. Okay, this one says the same thing to me, that the function left and right at negative 2 is undefined. I'm going to say it's a vertical asymptote. On the left, as x approaches negative 2 from the left, it's negative infinity. Done. And from the right is positive infinity. All the information is summarized in this table. Now I can come up with my example of the graph. So let's do that. I will graph my horizontal asymptote, although this is an overkill. There is really no need for that, but I want to emphasize my findings. At -2, I will draw a vertical asymptote. I will label it as x equals -2, as well as +2. I will label it as x equals 2. I will create my point 0, 0 right here. And then I'm looking at the left branch from 0 to -infinity, no problem, from 0 to -infinity. Then undefined, then from +infinity to 0, and then going again back to +infinity. Undefined at 2, and then from +infinity dropping to 0. This is my example of the function. Is there another? Of course. Here's another example for you. On this side, I can do this. I can do this. No, from here it has to come from here. I can do whatever. Yes, Ricky?
Is this 2.5 or this
This is 2.6, limits at infinity, an example. So it's problem 6 on page 140. Any questions? Any questions? I would like to look at a problem with a function that we have not reviewed yet. So let's review it now. Let's go back to the list of functions again. So please do not forget the following functions. We will need them forever in math, not just in this course. The first one is tangent x. Arc tangent x or tangent inverse x. It doesn't matter. Both mean the same thing. The graph of 1 over x. Very important to remember. The graph of natural log. Very important. It crosses at 1. And now I would like to add the graph of function 1 over x. I meant e to the x, of course. Since I mentioned 1 over x, I'm going to graph that too. 1 over e to the x. It's x to -1. I don't need this one, but I mentioned it so. This is what I'm interested in. And I want 2 limits on this function. Because now we know all sorts of limits. Can anyone give us the limit of e to the x as x approaches infinity, and limit of e to the x as x approaches -infinity? And I'm going to ask the same 2 questions about limit as x of natural log x as x approaches infinity, and limit of natural log x as x approaches 0 from the right. That's why we go back and forth with these functions. That's one of the reasons for limits. So can anyone give us the limit of e to the x as x approaches infinity? Very good. Indeed, positive infinity. Awesome. Can anyone give us the limit of e to the x as x approaches -infinity? Perfect. So what do I conclude about y equals 0 for e to the x? At -infinity only. Very good. So limit of e to the x as x approaches -infinity is 0, which makes y equals 0 a horizontal asymptote only at -infinity. Very good. So now let's put this 2 together with the graph of natural log. So limit of natural log as x approaches infinity. We look at the graph of, I'm sorry. We look at the graph and we conclude that the limit is, say it again. Of course, very good. Good. And now for natural log, can I ask you the limit as x approaches negative infinity? No, the function is defined only on 0 to infinity. The domain is 0 to infinity. Yes, Ricky? So now I want natural log, limit of natural log as x approaches 0 from the right. Thank you. Indeed, negative infinity. And of course, x equals 0 is a vertical asymptote. So having all this information, we are ready for another limit. And here's the limit. I'm looking at 34 on page 141. Limit as x approaches infinity from e to 3x minus e to negative 3x divided by e to 3x plus e to negative 3x. And you can say, what is this? Here's my first question. We have to establish what it is, right? So which of these two, when x approaches infinity, is the most powerful? Say it again.
E to the 3x.
Of course, right. Because what is this? Can anyone tell us what that is? E to negative 3x. No. 1 over e to 3x. So when this approaches infinity, this approaches this approaches, and 1 over infinity will approach, correct. So obviously this is the most powerful. So like remember with the degree, this is what I'm going to factor out. So limit as x approaches infinity, e to 3x, e to 3x. It happens that this time both the top and bottom are the same. But now the question is, what is left in parentheses? Obviously 1 in both cases, minus and plus. But now, what is left from the second term? Bless you. I think they made it a little bit warmer. Then is it we agree or not really? Okay. So what is left? Such that this times this is that. Yes, E2. Very good. Very good. So how do I get that? Multiply, copy the base, add the exponents. 3x minus 6x is negative 3x. Very good. Very good. What do you think I'm going to do next? Oh, of course, they are the same. And now I'm going to ask you again, where does this go? Excellent, because of the negative power and because x approaches infinity. Okay, where does this go? And what is the limit then? 1, which means for this particular function, 1, horizontal asymptote at infinity. Very good. Very good. Any questions? Any questions for me? Any questions? Yes, Ricky?
How did you get negative 6x after the
Very good question. So one possibility would be that you imagine that e to negative 3x was divided by e to 3x. Because I pulled out an e to 3x, which means I'm dividing by it, right? So I copy the base, and from the exponent of the numerator, I subtract the exponent of the denominator. So that's how I get e to negative 6x. Now, another possibility would be, as I started, this times what is that? Well, only if I have the power negative 6x, when I multiply them, I copy the base and I add the exponents to get that. 3x minus 6x is negative 3x. Or I imagine that I divide. Because when I pull out something, I'm basically dividing each term by it. So this times 1 is that, and this times this is that. Better?
Because you multiply exponents.
I copy the base and add the exponents. When I distribute, this times this is this. I copy the base and add the exponents to get that. So 3x minus 6x is negative 3x. Or you say I'm dividing because I pull out, I factor out. So I'm dividing e to negative 3x by e to 3x. Copy the base, subtract the exponents. So that's how I get e to negative 6x. Better? Everyone, any questions? Any questions, please? Anyone? Yes, please. Dylan?
Why did you rewrite it as e to the power of negative 3x equals 1 over e to the power of?
And that is the rule from exponential rules. So we have a to negative n is 1 over a to the nth power. So the meaning of any negative exponent is a fraction 1 over a to the positive power. I just wanted to explain why this will approach 0. And between these two, this is most powerful when x approaches infinity. If x approaches negative infinity, this one is more powerful than this. But when x approaches infinity, this dictates, and this is tiny. It's 0, basically. Is that better?
Yeah.
So that was the rule I wanted to remind everyone just to make sure we are on the same page. Anything else for me from this section, or we move on? Yes, please, Vanessa. With? Oh yeah. So let me see if there is. Yeah. So we can look at let's say 35. I just don't. I couldn't come up with something fast that is similar. I can just change the exponent and change it from negative 3 to negative 5. That would be a quick fix for you if that's what you want.
Will it always be, obviously won't, but like, how would you figure out the different exponents?
I have to look at the problem. I can't give a recipe without looking at the problem. I can't say that this particular recipe works for all situations or in all situations. But if you have a problem, I can look at it. So for now, if you want, we can look at 35. So 35. On the same page, 141, we have limit 1 minus e to the x as x approaches infinity, and the denominator 1 plus 2 e to the x. So again, we have to establish what here, of course, remember this is infinity over infinity. Otherwise, I wouldn't need to do any of that. So where does the top go? Perfect. Where does the bottom go? Right. Even if it's negative, it doesn't really matter. It's the same thing. So let's look at what will I pull out from the top? Very good. What will I pull out from the bottom? E to the x. Very good. So now we have to establish carefully what we have left in parentheses. Very good. 1 over e to the x, and then minus 1. Perfect. And the next one. 1 over e to the x plus 2. The next step would be, yes, I'm canceling these two because they are the same. And then where does this go when x very carefully approaches infinity? Very good. This approaches 0. Where does this go? And then the answer would be? Very good. Very good. What do we conclude about this function then? For sure. Y equals negative 1/2 is a horizontal asymptote at infinity. And I lost track of so that was 4, 5, and 6. Any questions, please? Any questions? Any questions? Yes? Exponential. These are exponential functions. Not if I get the answer as being infinity. The horizontal asymptote requires that the answer when I determine the limit at infinities is a number. But if I get infinity or negative infinity, a function cannot have a horizontal asymptote. The answer must be a number. Then it's a horizontal asymptote. But if this answer is infinity or negative infinity or DNE, there is no horizontal asymptote.
How would you know if it's a vertical asymptote?
When I determine x approaching x, a number,
Okay.
not an infinity.
Okay.
At infinity, I'm testing horizontal asymptotes.
Okay.
But when I determine x approaches 2 from either side or from one side or the other, and I get infinity, that is a vertical asymptote. That's why, it's a very good question. That's why I wrote these two here. This one for the limit, for the natural log, and this for the exponential. This one does not have a horizontal asymptote, but this one does. This one doesn't have a vertical asymptote, but this one does. So you should think of these two functions together. They are inverses of each other anyway. Very good question. Thank you. Anything else? Other questions here? So I think